Let's look at square root addition and subtraction. For example, let's add these two numbers together. The first thing we'll do is we'll simplify each of the square root terms by extracting all perfect squares. In other words, this is equal to 5 times the square root of 9 times 5. 45 is equal to 9 times 5, and 9 is a perfect square. And then plus the square root of 4 times 5. 20 is equal to 4 times 5, and 4 is a perfect square. And now by properties of radicals, this is equal to 5 times the square root of 9 times the square root of 5 plus the square root of 4 times the square root of 5, which is equal to 5 times the square root of 9, which is 3, times the square root of 5, plus the square root of 4, which is 2, times the square root of 5, which is equal to 15 times the square root of 5, plus 2 times the square root of 5. And finally, we can combine these. If we have 15 square root of 5 plus 2 more, then we have 17 square root of 5, which would be our answer. All right, let's look at another example. Let's simplify this. Again, let's start off by simplifying each square root term by extracting all perfect squares. In other words, we can write 27 as 9 times 3, and 9 is a perfect square. And then we can write 75 as 25 times 3, and 25 is a perfect square. And finally, we can write 12 as 4 times 3, and 4 is a perfect square. Again, by properties of radicals, this is equal to the square root of 9 times the square root of 3, and then plus 3 times the square root of 25 times the square root of 3, minus 2 times the square root of 4 times the square root of 3, which is equal to the square root of 9 is 3, so we have 3 times the square root of 3, plus 3 times the square root of 25, which is 5, times the square root of 3, minus 2 times the square root of 4, which is 2, times the square root of 3, which is equal to 3 times the square root of 3, and then plus 15 times the square root of 3, and minus 4 times the square root of 3. Again, we can combine these. We have 3 square root of 3 plus 15 square root of 3, which is 18 square root of 3, minus 4 square root of 3. So we're left with 14 square root of 3, which would be our answer. All right, let's see one more. Again, we'll start by working with each square root separately and extracting the perfect squares. In other words, this is equal to 5 times the square root of 24. But 24 is 4 times 6, and 4 is a perfect square. Minus 4 times the square root of 32, but 32 is 16 times 2, and 16 is a perfect square. Plus 3 times the square root of 18, and 18 is 9 times 2, and 9 is a perfect square. Minus 2 times the square root of 54, and 54 is 9 times 6, and 9 is a perfect square. Again, by properties of the radical, this is equal to 5 times the square root of 4 times the square root of 6 minus 4 times the square root of 16 times the square root of 2 plus 3 times the square root of 9 times the square root of 2 minus 2 times the square root of 9 times the square root of 6, which is equal to 5 times the square root of 4, which is 2, times the square root of 6 minus 4 times the square root of 16, which is 4, times the square root of 2, plus 3 times the square root of 9, which is 3, times the square root of 2, minus 2 times the square root of 9, which is 3, times the square root of 6, which is equal to 10 square root of 6 minus 16 square root of 2 plus 9 square root of 2 minus 6 square root of 6. Now what's different here that we didn't see in the last two examples is we're left with two different types of radicals. We have the square root of 6 in two terms and the square root of 2 in the other two terms. So we'll combine terms with common radicals. That is 10 square root 6 minus 6 square root 6 would leave us with 4 square root 6. And then negative 16 square root 2 plus 9 square root 2 would be minus 7 square root of 2, which is our answer. And this is how we add and subtract with square roots. Thank you, and we'll see you next time.